Okay. Can you hear me? Can you hear me clearly? Just send me a message. Can't hear. Yes. Uh, okay. Now can you hear me? Yes. Okay. Okay. So we'll start. So good afternoon. Uh, yes. Today we are starting our O-level express rapid revision for the O-level students who are going to face your exam in 2025. Now, yes, you all have 6 months to go, I think. You all have 6 months to go. So, how about your preparation now? Are you well prepared for the exam? Or are you in a questionable area? What about your situation now, current situation? Are you confident enough to sit for the O-levels? Silence. Silence means yes. Okay, anyway. So, I don't want you to be confident about your exam at the moment. At the moment, I don't care what your level is, even if you are in the 0 level, or even if you are in middle levels in 20s, 30s, or 40s, or even if you are in higher levels, it doesn't matter. So before starting, I'll tell you something about this program, our revision plan. So here we are going to start from the beginning. Today, when I start the lesson, you will understand we are going from the beginning. Okay. So from the 0 level to the exam level, we are covering in this class. Okay, from the 0 level to the exam level, we are covering. So I uploaded an introduction video. I hope you all have watched it. So there I'm telling that we are covering this whole syllabus through 14 units. Now I hope you all know about the exam structure. Okay, I hope you all know about the exam structure. So my target is to cover that entire paper just through 14 units. And I have listed those 14 units in that introduction video. You can see that. Okay. In that introduction video, you can see that one. So I'm not going to explain that one here. So today I am starting the lesson algebra. Okay, I'm starting the lesson algebra. So entirely through this lesson, you can get more than 15 marks. More than 15 marks. Here in this lesson, I am targeting these areas. Okay, we are starting from the very beginning. We are starting from the very beginning. What is algebra? What are algebraic symbols? And what are algebraic terms? Everything will be discussed in the class. And I sent you the tut also. There also everything is mentioned there. Okay. And the other and after that, we are talking about algebraic expressions, factorizing, and everything. And after that, LCM of algebraic expressions. And after that, we are talking about algebraic fractions. Okay. And then we are coming to the equation lesson. Today, we are not starting equations, but later we are starting equations, probably tomorrow or next week. Okay. So basically my target is to cover the quadratic equation question. Okay. In the exam paper, there is a full question from quadratic equations. And also there is another full question from simultaneous equations. So my target is basically covering those two questions through this unit. In addition to that, okay, in addition to those two questions, more than 5 short questions are coming from the unit algebra. In the first paper, we know, in the first paper, we have 25 short questions and 5 structured decisive questions. So from those 25 short questions, more than 5 marks will be able to get from this unit. Different things, factorization, algebraic expressions, find the least common multiple. So like that, they will give some questions you will be able to answer. And the other thing is, I know, even though I'm talking like to strangers, I know most of you, I know about most of you personally, our previous students. So I know your level. Most of your level, I know. So the thing is, now you are joining this class because you want a knowledge from the beginning. You want to get the knowledge from the beginning and be prepared for the exam. And that's why you join for this class. So now the thing is, we don't have much time. Yes, I told you, I'm telling in videos and everything, I'm telling that we have enough time, but actually we don't have much time. Okay, we have just 6 months. We have to cover up an entire syllabus, and after that we have to do papers, and not only mathematics, you have to, along with mathematics, you have 8 more subjects. Altogether, you have 9 subjects. So today, from today onwards, a tough time is starting for you. Also for me. Okay. Today we are starting a tough time. Like a big training. So the number one thing I need from you is a discipline. Before starting, you should promise yourself that you will be spending these 6 months with a good discipline. Discipline is not the way you are behaving or you are dressing, not that one. Discipline means you have to keep a discipline on this work. Okay. You have to keep a discipline on this work, and you should be honest to yourself, not to me. Now, this one is an O-level rapid revision. Therefore, I'm not going to check each other's work like a grade 5 class or grade 6 class. I'm not going to ask whether did you do homework, did you try that question, and after that, if not, if you haven't done that one, I'm not going to call your parents and punish you. I'm not going to do those things. That part is up to you. What I'm doing here is covering the entire syllabus as I promised, and doing papers and discussions, and after that making you ready for the exam. That is my part, and I'm doing that part. You should have a discipline. Okay, you should have a discipline to do what I say and to level up yourself. So only if you can do that one, you will be succeeded, and if not, it will be a problem. If not, the mission will be failed, actually. So then we'll start our work. Today we are starting the unit algebra. So keep a promise to yourselves. You can, definitely we can do this one. 6 months is a big time, but also we have a big work to do. So time is enough. So yes, 50% is for me and 50% is for you. I'm doing my 50% in my best, and your 50% also should be come at your best. Okay. So we'll start. Today our lesson is algebra. Today our lesson is algebra. Okay. Tell me, what is algebra? Now you all have heard about this word: algebraic terms, algebraic expressions, algebraic symbols. Okay, you may have heard. What is algebra? What do you mean by algebraic symbols? What do you mean by algebraic symbols? The other thing is try to get interacted with me. Yeah? Unmute yourself and ask questions. Give the answers to the questions that I ask. So this one should be an interactive class. If not, it will be boring for you and also it will be boring for me. Okay, can someone tell me what are algebraic symbols? Yes? Any volunteers? Or else you can send me a message or something through a message. No one? Okay. Now have you seen in mathematics, in papers, so in questions, we use simple English letters. Mostly we use X, okay, Y, simple A, simple B. We use these kind of letters. These letters are called algebraic symbols. These letters are called algebraic symbols, X, Y, A, B, C, D, E, F, G, H, anything you can use, but in simple. Mostly we use simple letters. Okay. These letters are called algebraic symbols. And why do we use these things? Why are we using these letters in maths? Now, basically, maths is based on numbers. But why do we use these letters instead of numbers? The purpose of using these letters is representing an unknown value. We use these letters, simple English letters, to represent an unknown value. Okay. For example, if I use this one, you know what is the meaning. This one is also a symbol. But we know the exact value of this symbol. The value of this one is 5. Okay, this is 5. But we'll take an example. What? Okay. The number of students in Sri Lanka. Number of students in Sri Lanka. Now, do you know the number of students in Sri Lanka? School students in Sri Lanka at the moment? No, I don't. I don't think. Even I don't know. So that value for that one, we can't use a symbol like this. To represent the number of students in Sri Lanka, we can't use this symbol. Why? It has a fixed value. The value is 10. If you use this one, it means the number of students in Sri Lanka is 10. But that is not true. Okay, so we can't use that one. But I can use this. We can take the number of students in Sri Lanka as X. Actually, we don't know the number of students in Sri Lanka at the moment. Therefore, that is an unknown term. To represent an unknown term, we can use a simple English letter in mathematics. Okay, we can use a simple English letter. So, those letters are called algebraic symbols. Okay, those letters are called algebraic symbols. Another example. If I ask you, I have a number of apples with me. At the moment, I have some apples with me. You don't know what is the number of apples that I have. I ask, what is the double of that number? Could you answer that one? I have some apples with me now. Okay, at the moment, I have some apples. If I ask you, what is the double of that number? Could you answer that? Can you answer? What is the double of the number of apples that I have at the moment? You can't answer. Why? You don't know the number of apples I'm having now. You don't know the number of apples that I have now. You don't know. Therefore, you can't find the double of that. If I say like this, I have five apples at the moment. I have 5 apples with me. What is the double of this number? Then you can say 5 times 2. that is 10. Then you can say it is 10. But if you don't know the value, you can't get an answer like this. Instead of getting an answer like this, you can take it like this. The number of the apples that I am having is A. We don't know the value. You don't know the value. I know, but you don't know. So you can take the number of apples that I have as A. Double of that one is multiply that one by 2. That is 2A. Now then you can say, if the number of apples that I'm having is A, the double of that one is 2A. Okay, double of that one is 2A. So I can use it like that. That is how we use algebraic symbols in our mathematical works, in our calculations and everything. Okay, so basically what you have to know is algebraic symbols are the simple English letters. Algebraic symbols are the simple English letters that we use to represent an unknown value. Okay. So that is the introduction about algebraic symbols. Okay. Now there are some technical words in this in this unit. Okay. There are some technical words. Now you may have heard those things. You may have used those things also. But still, some of you may not be not having a proper understanding about the meaning of those technical words. So it's very important to have a understanding about those technical words. Then we'll come to the next part. The next part is, wait, give me 1 second. Someone is asking for the link. Okay. Now, this one is an algebraic symbol. If I multiply this algebraic symbol with a number, if I multiply this one with a number, 2, I chose x, I multiplied that one by 2, then 2x. I multiplied an algebraic symbol with a number. We'll take another one, y, and I'm going to divide this one with a number, y over 3. I divided this one by 3. When you multiply an algebraic symbol with a number, or when you divide an algebraic symbol by a number, we call it, the answer is called an algebraic term. We call it an algebraic term. Okay, when an algebraic symbol is multiplied or divided by a number. When an algebraic symbol is multiplied or divided by a number, it is called an algebraic term. Okay, it is called an algebraic term. So 2x, it's an algebraic term. Y over 3, an algebraic term. Okay, another one. Yes, 3a, algebraic term. An algebraic symbol is multiplied with a number. So answer is called an algebraic term. Other part is, you can multiply an algebraic symbol again by another algebraic symbol. Then also it is called an algebraic term. So for example, I'll multiply 2x by y. I'll multiply 2x by y. So answer is 2xy. This is an algebraic term. This is also an algebraic term. I multiplied that algebraic term with another algebraic term. Then the answer is also an algebraic term. So 2xy. So we can write so many algebraic terms like that. Now you know about these things. I'm just telling the background. Okay. Here these things have you seen? 4a squared y. Algebraic term. 4 and a is multiplied again with a multiplied by y. This one is an algebraic term. Okay. 3y cube x divided by z. Algebraic term. All are multiplied or divided. Multiplication and division has been done. So, an algebraic term. So, that is about algebraic terms. When you, in the tutor I have mentioned, the products or quotients of numbers and algebraic symbols are called algebraic terms. Do you know what is a product? Do you know what is the meaning of the word product in mathematics? Yes, I hope you all know, but I'll quickly remind those things. We have four basic.
Excuse me, sir.
Yes.
Can I get the tute, please? Where can I get it?
Are you not in the group?
Okay, sir.
I have sent the tute to the group. I have sent the tute to the group. Yes, so these are the four basic operations in mathematics. Okay, whole entire mathematics is built up on these four operations. These are the four basic operations. We can group them. Here we have four operations. I can group them into two like this. Here, I can group them like this. Keep this basics in your mind. Okay. Normally, addition and subtraction comes under one group. Division and multiplication comes under another group. Okay. We call these groups operational couples. Operational couples. Okay. So this is one operational couple. This is another operational couple. The reason of doing like this is normally in almost every situation, addition and subtraction, they behave as friends. That means they behave in the same way. They behave in the same way. They follow same rules. They follow a same set of rules. So they are called a group, like they are acting like a group, like friends. So these two are called a one operational couple. And when it comes to division and multiplication, they behave in the same way. They are following a same set of rules. They need the same requirements. They follow same set of rules. So they behave like another group. So then these two are separate operational couples. Okay. And the other thing is, we have four special names for these operations. When you add two numbers or two terms, anything, when you add two things, for example, if you add 2 and 3, the answer is called the sum. When you add two numbers, answer is called sum. Okay, so if someone asked, not S-U-M-E, not S-O-M-E, this is S-U-M. You all know these things, I'm just revising. Huh? If someone asked, what is the sum of 2 and 3? Sum of 2 and 3. Sum means addition. So you have to add 2 and 3. 2 plus 3, answer is 5. Okay, 2 plus 3, answer is 5. Sum. When two numbers are added, the answer is called sum. When a number is subtracted from a number, the answer is called the difference. Okay. When a number is subtracted from another number, the answer is called the difference. If someone asked, what is the difference of 2 and 3? What is the difference of 2 and 3? What is the difference between 2 and 3? What is the answer? 3 minus 2. Answer is 1. What is the difference of 4 and 6? 6 minus 4. Answer is 2. Difference is 2. So difference. Okay. When you divide a number by another number, for example, 6 divided by 2. 6 divided by 2. When you divide a number by another number, answer is called quotient. Answer is called quotient. When you divide a number by another number, answer is called quotient. These are very basics, but we need these things. When two numbers are multiplied, with each other, the answer is called product. The answer is called product. Okay. Product of 2 and 3, 6. Product of 2 and 5, 10. 2 times 5. Okay. Product of 3 and 5, 15. Product means multiplication. So that is these are the 4 basic operations, and we learned to couple them, and we named them as operational couples. Addition and subtraction lie in the same couple. They behave in the same way. Division and multiplication, they are in the same group. They behave in the same way. So these are the special names given to the answers that you obtain by doing these 4 basic operations. When two numbers are added, answer is sum. When a number is subtracted from another number, then the answer was called difference. When a number is divided by a number, it was called the quotient. And when two numbers are multiplied, the answer was called product. Okay. So that is about, I'm just preparing the background, preparing the surrounding environment. Okay. So the product of a number and an algebraic symbol is called an algebraic term. This is an algebraic term. Okay, a product of a number and an algebraic symbol. Also, product of 2 or more algebraic symbols is also called an algebraic term. Product of 2 or more algebraic symbols is also known as an algebraic term. Also, quotient, x divided by 2. Quotient of an algebraic symbol and a number. An algebraic symbol is divided by a number. This is also an algebraic term. So like this, 2x squared y divided by 3, all these are algebraic terms. Okay, so we learned about algebraic terms and algebraic symbols. We learned about them. Now, the next part. When you add an algebraic symbol with a number, or when you subtracted the number from an algebraic symbol, simply a sum or a difference. A sum or a difference of algebraic terms is called what? An algebraic expression. A sum or a difference of algebraic terms. That means now we know what algebraic terms are. When you add two algebraic terms, it is called an algebraic expression. When you subtract an algebraic term from another algebraic term, it is called an algebraic expression. Okay. Now, did you understand the previous thing that I told about operational couples? Okay. When two algebraic symbols are multiplied or divided, multiplication and division. When two algebraic terms are multiplied or divided, it is called an algebraic term. When two algebraic symbols are multiplied or divided, it is called an algebraic term. When two algebraic terms are added or subtracted, their addition and subtraction, then it is called an algebraic expression. So these things are algebraic expressions. For more example, we can take here x squared plus 3x, algebraic expression. X cubed plus 2x squared plus 3x. This is an algebraic expression. All these are algebraic expressions. Okay, so that's it. I'm just telling the meanings of these words. Okay, I'm telling the meanings of these words. You have been using these words for a long time, but not knowing all their meanings. What else? Yes, now when we are taking an algebraic expression, for example, I'll take an algebraic expression 2x plus 5. This is an algebraic expression. Now we know here an algebraic term is added to a number. The addition, this one is an algebraic expression. There are different parts. In an algebraic expression, we have different parts. Now let's see what are these parts. Okay. Here in the dude I have mentioned. Now here we have two algebraic terms. This algebraic expression is made up of two algebraic terms. That is 2x and 5. These two are called terms. So this algebraic expression has two terms. Okay. In an algebraic expression, simply things that are separated by a plus or a minus mark. Things that are separated by a plus or a minus mark are called algebraic terms. Okay, terms of that expression. So in this expression, we have two terms. Here, we know the value of this one. This is 5. No matter what happened, this is 5. Okay. But do we know the value of this term? Do we know the value of 2x? No, we don't know. We don't know the value of 2x. Why? This is the algebraic term. It is the term containing an algebraic symbol. Algebraic symbol means we don't know the value. So this value can be different. Depending on the value of x, the value of this term can be different. For example, if x is 3, then 2x means 2 times 3, 6. If x equals 3. What if x equals 4? If x equals 4, then 2x means 2 times 4, 8. Here, if x equals 6, 2x equals 2 times 6, that is 12. See, when the value of x is changing, the value of this term is changing. Okay, the value of that term is changing. Therefore, we call this term a variable. We call it a variable. The value is changing. We call it a variable. Okay, value is changing. Constantly it is changing. This is a variable. Okay, simply in an algebraic expression, the term containing an algebraic symbol, is called a variable. I'll, for example, here 3x squared plus 9. 3x squared plus 9. This is the term containing an algebraic symbol. Here, x is an algebraic symbol. Therefore, this is the variable. This is the variable. Okay. See, no matter what is x can be anything, but 5 is 5. X can be anything, x can be 2, 3, 4, 5, anything, but 5 is 5. It doesn't change. Does it change? Will the value of 5 change when this one is changing? No, it doesn't change. Here, x can be anything, 3x squared can be anything, but 9 is 9. It doesn't change. Okay, it has a constant value. 9 is a constant value. And therefore, this is called the constant. This is called the constant. Okay, so in this expression, variable is 2x, constant is 5. In this expression, variable is 3x squared, constant is 9. Okay, I'll take a long one. 2x cubed plus 3x squared plus 4x plus 9. Now, in this expression, we have 4 terms here. 1, 2, 3, 4. We have 4 terms. All these 3 terms are contained in an algebraic symbol. All these 3 terms are containing an algebraic symbol. X is there. Therefore, value of these terms can be changed. When x is changing, their values will get changed. So, all these 3 terms are variables. Okay, all these 3 terms are variables. But no matter what the value of these 3 terms are, 9 is 9. It doesn't change. No matter what they take, no matter what is the value they are taking, 9 is not affected. 9 is 9. Okay, it doesn't change. So here we have 3 variables, 3 variable terms, and 1 constant term, that is 9. Okay, that is about variables and constants. That is about variables and constants. There's another thing. What? Take this variable term, that is 2x. Okay, the number in front of the algebraic symbol. In an variable term, in an algebraic term, the number in front of the algebraic symbol has another name. Someone is raising hand. Muhammad Ashik. Why do you have any
Excuse
question?
me, sir.
Yes.
Will you upload this video on YouTube?
Yes, I'm going to upload. I was to cast this one on YouTube live, but suddenly a technical error came, so I couldn't go live. Anyway, I'll be uploading this one after the class. Yes, I'm recording it, so I'll be uploading.
Okay, sir. Thank you.
Okay. What? What did I say? Yes, this one. This is the variable term. In front of x is the algebraic symbol. In front of that one, we have 2. So the number in front of the algebraic symbol is called coefficient. Some people say coefficient, both are correct. I say coefficient. Okay. The number in front of the algebraic symbol is called coefficient. So here, 2 is the coefficient. Okay, we'll take another number. 3x squared y. 3x squared y. 3 is the coefficient. Okay, these are the algebraic symbols. 3 is the coefficient, the number in front of that. Okay, another one. 4x cubed y squared z. Coefficient is 4. 4 is the coefficient. Okay, 4 is the coefficient. Yes, so that is about variables, constants, and coefficients. You need to have a comprehension about these terms, these technical words. Yes, okay. We'll go on. The next part is in an algebraic expression, terms with the same variable are called like terms. Okay, for example, 2x plus 3x, not plus, I'll take 2x and 3x. Okay, 2x and 3x. In both these terms, variable part is x. Yeah, unknown part is x. Here also x. So no matter what is the number in front of that one, what are the coefficients, if they are unknown terms, if their algebraic symbols are same, then they are called like terms. Now here unknown term is x. Unknown part is x. Here also unknown part is x. So 2x and 3x are like terms. Another one. 2, always I'm taking 2. I'll take another one. 10. 10x squared y and minus 3x squared y. Okay. Can someone tell me whether they are like terms or not? 10x squared y and minus 3x squared y. Can you tell me whether they are like terms or not?
Yes, sir, they are.
They are like terms. Why? What is the reason? Their unknown parts are same. Here also unknown part is x squared y. Here also unknown part is x squared y. Okay, so they are like terms. We'll try another one. What about this one? Tell me. 2xy and 2xy squared. Are they like terms or not?
No, sir.
Why not? Here also we have x and y. Here also we have x
Yes,
and
sir.
y.
Yes. It's like both are like.
Look at this one. Here we have xy. But here we have xy squared. Even though we have x
Yes, sir,
and y
that's
in.
why I said you that. That's
Yes. Here we have xy. Here we have xy squared. Here y squared. Even though the symbols are same, these terms are different. They are not like terms. Okay. Here we have x and y. Here also we have x and y. It's okay. But here we have only one y. Here we have two y's. Therefore, these are not like terms. Here xy squared. Xy and xy squared are two different variables. So they are not like terms. Okay. So keep that in your mind very carefully. Keep that in your mind. What about this one? 5ab and minus 5 a squared b. Are they like terms or not? Are they like terms or not? 5ab and minus 5a squared b. Like terms or not?
so a squared means there are two a's, right?
Yes.
Yes.
Here,
Then they are not like to.
yeah, very good. Here 5ab means 5 and a and b are multiplied. Okay, 5 and a and b are multiplied. Here minus 5a squared b means minus 5 multiplied by a squared mean a multiplied by a multiplied by b. Here we have only one a. Here we have two a's. Okay. Here AB, here A squared B. Even though in both occasions we are having A and B, here AB, here A squared B, they are not like terms, they are different. Okay, they are unlike terms, not different. They are unlike terms. Okay, so you should have a good understanding about like terms and unlike terms. In an algebraic expression, we can add or subtract only like terms. Okay, in an algebraic expression, we can add or subtract only like terms. For example, if it is given like this, 2x plus 3x, are they like terms or are they unlike terms? Like terms or unlike terms? Yes, any volunteers
They
to
are
answer?
unlike like terms, sir, because both.
Ah, yes, unknown part is x. Here also unknown part is x. So these two are like terms. Like terms mean we can add these two. Here 2x plus 3x, altogether we have 5x here. We can add. I told you we can add or subtract only like terms. Okay, we can add or subtract only like terms. 3a squared b plus 2ab plus 4a squared b. Okay, do this addition and tell me the answer. Can someone tell me the answer for this one? I'll give you 1 minute. Okay, shall we check? Ah, here we have 3a squared b plus here 2ab plus here 4a squared b. Which terms can be added? Which term cannot be added? Can I add this term and this term? No one. Why is it hard? I told you we can add or subtract only like terms. So first check whether what are the like terms, what are the unlike terms. So here we unknown part is a squared b. Here unknown part is a squared b. Here unknown part is ab. Here unknown part is ab. Here unknown part is again a squared b. See, here we have a squared b. Here also we
Sir,
have a
then
squared
we can
b.
add a squared b plus a squared b, right?
Yes, then this term and this term are like terms. These two terms are like terms. Okay, these two terms are like terms. So I can add these two like terms, but here we have an a beta, not a squared beta. Therefore, this one and this one are unlike terms. We can't add. These two are also unlike terms. We can't add. We can add only like terms. So 3a squared b plus 4a squared b, altogether I write here, 7a squared b. We can't add this one to here, so write it separately, 2ab. This is the final answer. Okay, we can't add these two further because They are not like terms. Okay. We'll try some more. Only one, only one is answering me. Others also tell me whether you have doubts. So I don't know whether you are having doubts. So you understood this one. So
Sir,
don't.
your coverage is not stable.
My coverage.
Yes, sir. It was showing only one signal bar.
But here the coverage is okay. It shows okay. What's the matter? Wait, give me 1 minute. I think problem is others. What about you? Tell me whether you
Sir,
are having
now
other.
the signal is okay, sir. The two
Okay, okay.
signal bars are showing.
Okay, then okay. Yes, we'll continue. Other people, you also talk with me. If not, only one person is talking, I also feel asleep. Uh, yes, what are the like terms? What are the unlike terms? What are the terms that can be added? Which terms cannot be added? Tell me your answers. Try this out.
Sir, is that Z 2XYZ?
Here we have 12xy minus 3xy plus 2xyz. 2xyz.
Sir, then the first both are like terms and the last one cannot be added or minus.
Yes, very good. Here we have xy. Here also we have xy. So unknown terms are equal. Therefore, they are called like terms. 12xy and 3xy are like terms. So I can subtract 3xy from 12xy. 12 minus 3, that is 9xy plus. What about this one? Here unknown term is xyz. Unknown part is xyz. Z is also there. Here we have only x and y. Here z is also there. So this is not a like term. It cannot be added or subtracted. We have to write it separately. Okay. Did you get that one? I want you all to speak.
No, sir, I'm copied down.
You are copying down. Okay. So what I wanted to tell is only like terms can be added or subtracted. Okay. Only like terms can be added or subtracted. Shall I erase this one?
Okay, sir. It is.
Okay. Others, if you want more time, more, if you want more explanation, please tell me. Okay, that is about addition and multiplication. Sorry, addition and subtraction. Previously, I told you addition and subtraction follow the same set of rules. If addition is following a rule, subtraction is also following the same rule. So when it comes to algebraic expressions, the rule is only like terms can be added. So if addition requires like terms, subtraction also requires the same thing. Only like terms can be subtracted. Okay, so keep that in your mind. Now come to the other couple, multiplication and division. Multiplication and division. Okay, these two follows another set of rules. They don't want like terms to be there. They don't ask for like terms. They are okay with anything like or unlike. We can multiply or we can divide. Okay, it doesn't matter. They don't worry about that one. When it comes to addition and subtraction, a lot of conditions are there. They should be like terms. Okay, if they shouldn't be unlike terms, then only we can perform. Same thing happens in fractions also. I hope you all are okay with fractions. When it comes to addition and subtraction of fractions, so many conditions. Denominator should be equal and so on. But when it comes to multiplication and division, no conditions, anything okay. Here also same. When we are multiplying algebraic terms, okay, when we are multiplying algebraic terms, no need for them to be like terms, anything they can multiply. For example, 2x and 4y. They are not like terms, obviously. Here, this one is an x term, this is an y term. So, definitely they are not like terms, but they don't ask for like terms, they can multiply anything. Definitely we can multiply these two. Now, when multiplying algebraic terms, first you have to multiply their coefficients. First multiply their coefficients. Okay, first multiply the coefficients. After that, multiply their unknown terms. Here coefficient is 2, here coefficient is 4. First we will multiply 2 and 4. What is 2 times 4? That is 8. 2 times 4, 8. Now let's multiply the variables, the unknown parts. X multiplied by y, that is xy. Answer is 8xy. Simple. Answer is 8xy. Another one. Can you answer this one? 3a squared multiplied by minus 2b. 3a squared multiplied by minus 2b. Give a small try. I will give you 1 minute. And tell me the answer.
The 3a squared into minus 2b equal.
Yes.
Is that the
3a
question?
squared into minus 2b. What is the answer? Yes. Can you tell me the answer?
So answer is minus 6 a squared b.
Minus 6 a squared b. Yes, so when multiplying, first multiply their coefficients. Here coefficient is 3, here coefficient is minus 2. 3 multiplied by minus 2. So here 3 is plus 3. In front of this one, we can't see a minus mark or a plus mark. If nothing is there, definitely it should be a plus term, positive term. So first multiply the symbols. Here plus, here multiplied by minus. Plus into minus. What is plus into minus? Yes. When a plus term is multiplied with a minus term, answer is negative. Minus.
Negative.
2 times 3, 3 times 2, that is 6. Here we have a squared multiplied by b, a squared b. So answer is minus 6 a squared b. Okay. I hope you are okay with these sign multiplications. I hope you're okay. If you're not okay, now look at this one. When multiplying, same symbols, always answer is plus. Okay. When you are multiplying same symbols, numbers with same symbols, answer is plus. When you're multiplying numbers with different symbols, answer is minus. Okay. For example, if you are multiplying a plus number with a plus number, here also plus, same sign. Answer is always positive. Okay. If you are multiplying a minus number with a minus number, even though the symbols are negative, they are same. In both occasions, symbol is same. Same symbols mean answer is plus. Only condition is symbol should be same, then the answer is plus. If you are multiplying a positive value with a negative value, then signs are different. Answer is negative. Then signs are different. Answer is negative. Okay. So keep that in your mind, very basic. Okay. So that's it. When multiplying, first multiply the coefficients, after that come to the unknown terms, symbols. We'll try one more. Yes, can you try it? Minus 5pq multiplied by 2qr. Minus 5pq multiplied by 2qr. Give a small try. Again, I'll give you 1 minute. The people, you also answer me, yeah? Get the maximum chance. You are having the opportunity to ask and clear all the doubts, no? In large classes, you don't have that chance. What that sir is saying, you have to sit and listen. But here you can ask me and clear all your doubts. So get the use of that one. Yes, what is the answer here?
So answer is minus 10 p q squared r.
Okay, let's see. So when multiplying, first we have to multiply their coefficients. First we have to multiply coefficients. After that we have to multiply their numbers. So coefficients are here minus 5. Here coefficient is 2. So here minus value, here this 2 is not minus, therefore it should be plus 2. Then minus into plus, different symbols, when different symbols are multiplied, answer is negative. When different symbols are multiplied, the answer is negative. Then numbers, 5 times 2. 5 times 2, that is 10. Okay, so we multiply the coefficients. Now here we have p, q means p multiplied by q. PQ means P multiplied by Q. We have to multiply that one with, here we have Q multiplied by R. Now, PQ means P multiplied by Q. QR means Q multiplied by R. So this one multiplied by this one means P times Q multiplied by Q times R. So now here P multiplied by Q and Q multiplied by Q, indices we know, indices with same bases, then add the powers. Here two Q's are multiplied, therefore Q to the power 2, Q squared multiplied by R. Two Q's are multiplied, Q squared. And therefore, P Q squared R is the answer. Minus 10 P Q squared R is the answer. So guys, is that clear to you? Is it clear?
Yes, sir.
Yes, sir.
Yes, okay. Everyone, drop a message even. At least drop a message. If it is not clear, I can explain again. Okay. So yes. So these are the basic calculations regarding algebraic terms. Now, again, let's come to algebraic expressions. There are different types of algebraic expressions. Okay, there are different types of algebraic expressions. These classifications are done based on different criteria. Okay, one criteria is based on the number of terms we can classify algebraic expressions into groups based on the number of terms. For example, how many terms are here? How many terms are here? Tell me. Yes? Sorry? I'm asking how many.
One term.
Here we have only one term. I told you. Things which are separated by a plus or minus mark are called separate terms. Now here, 2 and x are not separated by a addition or subtraction mark. No, it is separated by a multiplication. Therefore, this one is a one term. If an expression is having only a single term, only one term, then those kind of expressions are called monomials. Monomials. Normally this word mono is used to represent one. Okay. Carbon monoxide, have you heard? Carbon monoxide. One carbon, one oxygen. Carbon monoxide, like that. Mono means one. Monooxide, one oxygen. Monomials mean expressions that are having only one term. So 2x, we can take it as an algebraic term. Also, we can take it as an algebraic expression. It's a monomial expression. Okay. 3a squared b. We are having so many things, but all are connected using multiplication, not separated by a plus or minus mark. Therefore, this one is a single term. Also, this one is an expression. We can take it as an expression with one term. Therefore, it's a monomial. Okay. What about this one? 2p squared q divided by 5. How many terms are here? In this one, how many terms are here?
One term.
There is also only one term. Why? Nothing is separated by plus or minus mark. All are separated by multiplication and division. Therefore, one term. Then this expression contains only one term. It's a monomial. Okay, monomial. So monomials are the expressions containing only one term. Yes. Come to the next type. This is one type. This is
So if division and multiplication comes,
yes. Now I'm going to do that one. What about this one? 2x plus 1. How many terms are here? Yes, tell me how many terms are there in this expression? Yes, I need your answers. How many terms are there?
One term.
One term, two terms. Two answers were there.
Two.
Two. Okay, let's see. I told you. Things which are separated by a plus or a minus mark, plus or a minus mark, are called separate terms. Now here, this 2x and 1 are separated by this plus mark. Did you see? This 2x and 1 are separated by this plus mark. Therefore, 2x and 1 are two separate terms. Here, 2x and 1 are two separate terms. Here, two separate terms. Therefore, this expression, the expression 2x plus 1, the expression 2x plus 1 has two separate terms. If an expression is having two separate terms, we call it a binomial. Have you heard this word, binomial expressions? You may have heard. Binomial means an expression having two terms. Okay, 2x plus 1. Here one term, here another term. So binomial expression. Again. How many terms are there in this one? 3p squared q plus 2pq. How many terms are there?
Two term.
Yes, here two terms. 3p squared q and 2pq are separated by a plus mark. Therefore, this is one term, this is another term. Two terms are there. If two terms are there, it is called binomial. Normally, the word bi is used to represent two. Bi means two. Bicycle, two cycles. Okay, two circles, two wheels, bicycle. So, binomial means two terms. What about this one? 2x squared plus 3x plus 1. How many terms are here? Just
Three
tell me how
terms.
many terms are there?
Three terms.
Here, see. 2x squared and 3x are separated by this plus mark. 3x and 1, they are also separated by this plus mark. These two terms are separated by plus marks. Therefore, they are three separate terms. They can be called as three separate terms. So, here we have three terms, 2x squared, 3x, and 1. We have three terms. If an expression is having three terms, we call it a trinomial. Okay, be familiar with these terms, trinomial. Normally, we use the word tri to represent three. Three angles, triangle, triangle. Three angles, okay, tri. Tri is used to represent three. So here we have three terms, therefore this is a trinomial expression. This is a trinomial expression. Okay, this is a trinomial expression. Another one. 3p cubed plus 2p squared minus 9. 3p cubed plus 2p squared minus 9. How many terms are here?
Three terms.
Yes, here also we have three terms here. One term, another term, another term. Therefore, Three terms mean trinomial. Three terms mean trinomial. I'll add one more. Now, how many terms are there?
Four term.
Here we have four terms. Here, this one, this one, this one, and this one, we have four terms. Okay, we have four terms. What is the name given to an expression with four terms? Normally, we give these separate names for 1, 2, and 3 terms. Yes?
Quadrillion thing.
Quadrill, no. If there are more than 3 terms, no matter it is 4 or 5 or 6 or 7 or 8 terms, it doesn't matter. We call all of them as polynomial. Polynomial expressions. Okay. Normally, poly means more than one. Poly means more than one. Okay. If you may have learned in science, polythene means polyethene, more than one ethene. Okay, leave it to science. Poly means more than one. Okay. So actually, binomials, trinomials are also a kind of polynomials. If an expression is having more than one term, we call it a polynomial. But if it has two terms, we call it a special name as binomial. Yes, it is also a polynomial, but it has another name called binomial. If it is having 3 terms, yes, it is a polynomial, but it has a separate name called trinomials. After 3 terms, we don't have separate names for each term, each number. We call all of them polynomials. Okay, so basically, the names that you meet in the O-level syllabus are binomials and trinomials. Monomials also we don't speak in the O-level syllabus. In the O-level syllabus, we are basically talking about binomials and trinomials. About polynomials, we are not talking about. No, we are not talking in O-level syllabus. Okay. So I told you, algebraic expressions can be categorized based on different criteria. So this is how we categorize algebraic expressions based on the number of terms. Based on the number of terms, we can categorize algebraic expressions like this. In addition to this one, there's another criteria. There's another criteria. What is that? We can classify algebraic expressions like this. Then I'll take 2x plus 1. Now here, unknown term is x. Unknown term is x. Here, what is the power of x? Can someone tell me what is the power of x?
1.
1, yes. Here the power of x is 1. Here power is not mentioned. Not mentioned means definitely it is 1. In an algebraic expression, if the highest power of the unknown term, now here unknown term is x. Highest power of that one is 1. Highest or lowest or only one x is here. No? So power is 1. In an algebraic expression, if the highest power of the unknown term is 1, it is a linear expression. Okay, it is a linear expression. In an algebraic expression, if the highest power of the unknown term is 1, it is a linear expression. Okay. Now look at this one. 3x squared plus 2x plus 5. 3x squared plus 2x plus 5. Now here, what is the highest power of the unknown term? Can someone tell me? What is the highest power of the unknown term?
Square.
Here, unknown term is x term. Here we have x, here also we have an x. Here we don't have a x term, no, so just leave it that. Forget about that. Here the power is, here no power, therefore power is 1. Here power is 2. Here the power of unknown term is 2. Here the power of unknown term is 1. So the highest power of the unknown term is 2. In this expression, the highest power of the unknown term is 2. In an expression, if the highest power of the unknown term is 2, we call it what? Do you know the name? Yes. If the highest power is 2, what do we call it? You know. Starts with Q. No one. Quadratic expression. You all have heard this word, I think.
Yes, sir.
Yes, you all have heard. If the highest power of the unknown term is 2, it is a quadratic expression. Okay, quadratic expression. Now, this one. 4x cubed plus 3x squared plus 2x plus 5. And the minus also minus 5. Now, in this expression, what is the highest power of the unknown term?
Square.
Yes, what is the highest power?
Cube.
Sorry?
Cube.
Yes, cube. 3. Highest power is 3. X cube is the highest one. Yes, good. Therefore, if the highest power is 3, we call it a cubic expression. So, if the highest power is 1, linear expression. If the highest power is 2, quadratic expression. If the highest power is 3, that is cubic expression. Okay, cubic expression. So, that's about the different types of algebraic expressions. Okay, so now we talked about what? From the beginning, if we are revising quickly, at the beginning we were talking about the meaning of algebraic symbols. What do we mean by algebraic symbols? Okay, simple English letters that we use to represent unknown terms are called algebraic symbols. When an algebraic symbol is multiplied with a number or another algebraic term, another algebraic symbol, or if two algebraic symbols are divided, we call it an algebraic term. Okay. When two or more algebraic terms are added or subtracted, we call it an algebraic expression. So we divided algebraic expressions into 4 categories based on the number of terms. Based on the number of terms, we divided algebraic expressions into 4 categories. If there is only one term, we call it, what do we call? If there is only one term? Yes, I couldn't hear.
Expression.
Sorry?
What, sir? Sir, can you please repeat the question?
Meaning.
In an algebraic expression, if there is only one term, we call those kind of algebraic expressions as
Linear.
Monomials.
Monomial.
Monomials. If there are two terms,
Binomial.
binomial. If there are three terms,
Binomial.
three terms.
Trinomial.
Trinomial. Trinomial. Okay. Two terms, binomial. Two means bicycle, binomial. Three terms, trinomial. Three angles, triangle. Okay, like that. Three terms, trinomial.
Okay, sir.
More than three terms, what do we call?
Binomial.
More than three.
Polynomial.
And polynomials. Okay. So monomials, binomials, trinomials, polynomials.
Sir, you
That
said
is
more than one term is known as polynomial, right?
yes. More than one terms, we call them polynomials. But
But
only
each one term,
yes,
two term, and three term has separate
separate special names. Yes, very good.
special name for it.
Special names. They are also polynomials, but they have a special another name also. Good. The next criteria is based on the highest power of the unknown term. We can classify algebraic expressions again. If the highest power is 1, we call it a linear expression. If the highest power is 1, we call it a linear expression. If the highest power is 2, we call it a quadratic expression. We call it a quadratic expression. If the highest power is 3, we call it a cubic expression. Okay, so no need to study these things and keep by heart. Just have an idea about these things. Have an idea about these things. They can be useful in future. Okay, come to the next part. Okay, now you know these things, but I'm doing again. Can you guys read this one? How to read this?
X cube.
X cube.
We can read, yes, x cube. Or else we can read it as x to the power 3. X to the power 3. Now, I want you to expand this one. Expand it. How to expand this one? Yes? You know these things here? X to the power 3 means 3x letters are multiplied. 3x letters are multiplied here.
Yeah, sir.
X multiplied by x multiplied
X
by
into X
x.
into.
Yes, x into x into x. Okay, x into x into x. So that is x to the power 3. What about this one? 2x squared.
2x
Yes, this.
squared.
2x squared. Can you expand this one? You tell,
Yes,
I'll
sir.
write. Yes?
2x into 2x.
2 into 2x. Like this.
No, 2x into x. 2 into x.
2 into x into x. Okay, 2 into x into x. Correct. That is
Yes,
correct.
sir.
Now my question is this one. Tell me whether these two are same or different. X, Y, Z complete square. The other thing is x, y, z square. Tell me, are they same or are they different? Both these x, y, z whole thing square and x, y, z square, are they equal or are they different?
Different.
Sir, they are different.
They're different. Okay. So can you guys expand these two, this one and this one?
xyz into xyz.
Here the whole bracket should be multiplied twice. Ne? X, Y, Z multiplied by X, Y, Z. Okay, good. What about this one?
Z into z.
Sorry?
Z into Z.
Z into Z. What about X and Y? Yes. Here, X multiplied by Y multiplied by only this 2 belongs only to Z. Okay, that 2 belongs only to Z. You have to keep that in your mind. You should have a clear picture about that. Now, see, this 2 is outside this bracket. This power 2 is outside this bracket. Therefore, this 2 belongs to all these three unknown symbols. This 2 belongs to X, also it belongs to Y, it also belongs to Z. It belongs to 2. It belongs to all the terms inside the bracket. But here, 2 is not outside the bracket, they are not enclosed by a bracket. X, Y, Z square. Now this 2 belongs only to this Z. This 2 belongs only to this Z. Here, it belongs to X, it belongs to Y, it belongs to Z, it belongs to all these three. But here, this 2 belongs only to Z, it does not belongs to this X or Y. You should have a very clear idea about that one. Okay, is that clear?
Yes, sir.
Yes, very good. You should, it should be properly understood. Okay. Here, PQR cube means this cube, this 3 belongs only to this R. It does not have an effect on this P and Q. But if it is PQR whole thing cube, then this 3 has an effect on all these P, Q and R. It belongs to all these 3. Here it belongs to only this R. Okay, keep that in your mind. Very important. Yes. So that is the background of this lesson. Still, so we didn't start. Now, I have sent the tute. Did you all get the tute? No need to get printouts or anything.
Yes, sir, I got the.
Yes, sir.
Oh, you got it? Okay, then. I uploaded that onto the group.
Yes, sir, that's
Yes.
in the group.
Okay. Then all of you have the tute. There I have given some terms to expand you. Something is given like this. And you are asked to expand. How to expand this one? Yeah, I'm going with the very simplest place. We are starting this. I took this from your grade 9 book. So from grade 9 onwards, we are covering. So get the maximum use. Ask any doubt if you have, clear up it and go ahead. Okay, if not,
Okay, sir.
Yes, if not, it's a waste of time. Just don't misuse this last chance, because after coming closer to the exam, we don't have time to do these things. Then you have to go with the flow. Even if you're okay with maths or not okay with maths, you have to go with the flow. Okay. Then no time to do the basics and anything. You have to go with the flow. But now we have time. So still you can clear up all these things and go. So get the maximum use. Okay. How to expand this one? Simply, I want to remove this bracket. How to remove this bracket? Yes, any idea?
By multiplying all those terms in 5.
Yes. Here, what has happened is this bracket is multiplied by 5. this bracket is multiplied by 5. Therefore, when removing the bracket, you have to multiply each and every term inside the bracket by this 5. You have to multiply each and every term with this 5. So you have to multiply this x with this 5 and this plus 2 with this 5. Okay, so 5 multiplied by x, you have to multiply 5 and x, plus you have to multiply this 5 with this 2, 5 times 2. What is 5 times x? I can write it as 5x plus, what is 5 times 2? 5 times 2.
5 square. No, no. No, no, sir.
Yes, what is the answer then?
5.
10. Okay. 5 times 5 is 5 squared. Two numbers of 5 are multiplied, then 5 squared.
Okay, sir.
Here 5 is multiplied by 2, then
10.
5 times 2, that is 10. Okay.
Okay, sir.
Another one. Yes, give a try. I know these things are simple to you, but we'll go with the beginning. We'll go from the beginning. Then it's clear for you. Yes, tell me the answers.
3 into P.
We have to multiply each and every term inside the bracket with the number in front of that. So multiply both P and minus Q with this 3. Okay. 3 times P, that is 3P. Here, this 3 is plus 3. In front of it, we didn't have a plus or minus mark. We didn't have main, definitely it should be plus. So,
Plus.
Here plus, here minus, plus into minus. Plus, minus, different signs. I told you, if
Minus.
different signs are multiplied, the answer is
Negative.
negative. Good. Then answer is negative. 3 into Q, that is 3Q. 3P minus 3Q is the answer. 3P minus 3Q is the answer. Okay. We'll go to another one. Y multiplied by 2B plus 3. Y multiplied by 2B plus 3. Now, no need this one to be a number. It can be an algebraic term also. It can be an algebraic unknown symbol also. It doesn't matter. Yes. What is the answer?
We need to multiply every.
Yes, same thing, same thing. Here, each and
Y
every term
into
inside
2.
the bracket should be multiplied
Y
with the
into 2B, Y into 3.
multiply y by 2b, then normally y multiplied by 2b, normally we don't write it as y2b, okay? This is correct, but we don't write it like this. It's not a rule, but it's like a practice. We don't write like this normally. We write this number in front of the letters. 2yb, like this we can write. Or 2by. It doesn't matter. These two can be changed, but the number should be come first. So y times 2b, answer is 2by. 2by. Here y is plus, so plus into plus, answer is plus. Y multiplied by 3. Y multiplied by 3. Yes.
3y.
3y. Y times 3, 3y.
Sir.
We don't say y3, that is 3y. Okay, so another one.
So if your coverage is stable,
My coverage, I don't see a problem. What about others? Do you have any problem with the coverage? With my coverage?
No, sir.
Is the video getting lagging or something?
Sometimes.
Sometimes a little.
no sir, if someone speaks, the coverage is getting like.
When someone is speaking, no? Okay,
If
we'll see
someone
today
is speaking, the videos get like.
are getting lagged. Okay. So I think the weather is little bit bad today. I think it should be the reason. Okay, for today we'll manage. Tomorrow I'll solve the problem. Okay, minus 2 times x plus y. Minus 2 times x plus y. Give a try. Minus 2 times x plus y. Give
Again
it a
need to
try.
multiply.
What?
Again need to be multiplied, right?
Yes, same thing. All the terms inside the bracket should be multiplied with this minus 2. So, minus 2 multiplied by x plus, not plus here, minus 2 multiply with this y plus y. It is like this. So minus 2 times x, that is minus 2x. Here minus, here plus. Minus into plus, what is the answer? Minus into plus?
Minus
Minus 2 into y, that is
2.
2y. Minus 2x minus 2y. This is the answer. Okay, this is the answer. So another one. Minus 3 p minus q. P minus 2q. P minus 2q. Minus 3 times p minus 2q. Tell me the answer.
Minus 3p
Yes. Minus 3p
Plus. Minus.
plus
Plus.
plus
2q.
2q.
6q.
Any other answers?
6q. Sorry, sir.
6q. Yes. Minus 3 multiplied by p. Here we have plus p. Nothing in front, therefore plus p. Minus into plus, minus 3 into p, 3p, minus 3p. Okay. Minus into minus, here plus 3 times 2, 6. Here q, 6q. Then minus 3p plus 6q. So that is the answer. Minus 3p plus 3q. We'll try one more. Yes, last one in this type. Minus 2 multiplied by minus q minus r. Minus 2 multiplied by minus q minus r.
So minus into minus will become plus, right? Then The answer will
Yes.
come plus 2q or just 2q.
Minus into minus plus, yes, 2
2Q
into
plus
q, 2q. Again minus into minus plus 2 into r, 2r.
2r.
Yes.
So
Ah,
can't we write it just 2q and 2r?
you can normally in front of a number, if it is plus, we don't write plus. You can write it as plus, just 2q. But definitely you have to write this one.
Okay,
You
sir.
can't neglect that one. If you remove that one, then this one will be 2q multiplied by 2r. If
Okay,
there's
sir.
nothing between these two, it will be a multiplication. Therefore, definitely you have to write that plus. This plus, you can ignore that one.
Ignore.
Okay,
Sir.
2q plus 2r. Okay, good, correct. So yes, so you all are okay with that one. We'll move to a next part. What about this one? 3 times x plus y plus 2 times x minus y. 3 times x plus y plus 2 times x minus y. I want you to remove all these brackets and simplify as much as possible. Remove all the brackets, simplify as much as possible. Give it a try. Yes. Have you finished?
3x plus 3y
Let's remove the
plus
brackets. Okay. Here 3 times x, 3x, we know, plus 3 times y, 3y. Okay. Yes. Continue.
plus
Plus
yes sir plus into okay and 2x
2x.
yes and minus into plus minus
Yes, here plus into this minus, minus
minus y 2y.
2y. Okay. Yes, brackets are removed. Can you simplify this one further? What about your idea? Can you simplify it further?
Yes sir, we can by adding 2x and 3x.
Yes, I told you. Now this one is an algebraic expression. How many terms do we have? 1, 2, 3, 4. We have 4 terms here. Now we have to check whether are there any like terms or not. Now let's check whether is there any like term or not. Like terms mean in an algebraic term, if the variable part, if the unknown part is same, it is called a like term. So here unknown term is x. Here unknown part is y. Here unknown part x. Here unknown term y. Then here x, here also x. Unknown parts are same. Here unknown part is x. Here also unknown part is x. Unknown parts are same. Therefore, they are like terms. I'll take them closer and write 3x plus here 2x. See, Here y, here also y. Both are y terms, therefore like terms. Again, I'll take the like terms closer and write 3y minus 2y. We
Sir,
know
is
we can only add or subtract like terms. So these two are like terms. We can add 3x plus 2x, that is 5x. Here, like terms, 3y minus 2y. What is 3y minus 2y?
1y.
1y.
Y.
Y.
Just
Yes,
y.
no need to write y, 1. Just we can write y. So answer is 5x plus y. We can't add these two further. Reason is here an x term, here a y term. We can't add them. Okay. Yes. We'll try another one. Shall I erase this one?
Okay,
I'm
sir.
erasing. Okay. Give this a try. From the easiest ones, we are moving 3 times n plus n minus 2 times n plus n. Yes, give it a try.
Sir,
Yes.
3m plus 2, 3 2, sorry. 3m plus 3n.
Here 3 multiplied by m 3m plus
And
3
3
multiplied
multiplied
by
by
n 3n.
3n.
Okay.
And minus into plus.
Here we
Minus,
have minus. Here,
minus,
yes.
minus 2,
A minus 2
2m,
m. Yes.
minus into minus, plus,
Minus into minus plus. Yes.
2 into n, 2n.
2 into n, 2n. Yes, good. Now all the brackets are removed. Next, we have to check whether is there any like term or not. Now let's
Yes,
look
sir.
about
We can
like
add
terms.
3m plus 2, no, 3m minus 2m and
Yes, here m term, here also m term. Like terms. No, we'll take them closer and write. 3m, here we have not 2m, we have minus 2m. Minus 2m. Here n, here also n. So I'll take
plus
them closer. Plus 3n. Here plus 2n. Okay. Now I took like terms closer. Now what? Let's simplify the like terms. Simplify the like terms. 3m minus 2m. What is the answer?
m.
M, 1m, yes, m. Plus, plus, oh what? Plus 3, plus 3n plus 2n. 3n plus 2n.
3s plus 2n, 5n.
Plus 5n. So m plus 5n is the answer. Is that clear? Are you okay with that? Guys, are you okay with that?
Yes, sir.
Yes, oh, okay. We'll try some more. Yes, this one. Yes, with some amount of minus marks. Okay, give it a try.
Sir, 2 into 3.
2 into 3.
2 into 3. Sir, give me a.
Yes. Come, we'll remove the brackets. Multiply
6p,
each and every term with 2. Yes, tell me.
6p,
Yes, 2 times 3, that is 6. Here p, therefore 6p. Good. Then what?
minus
Minus
q,
q. What about this 2?
2q,
Minus 2q. Good.
plus
Plus
2p,
2p. Here we have minus. Here this p is plus. Therefore, minus into plus, different signs. When different signs are multiplied, answer is
minus.
negative.
Plus.
Oh,
Different signs. Okay,
here,
sir.
yes, yes. My bad. Here minus, minus into minus, that is plus.
Plus.
2 into q, that is 2q. Yes.
Okay.
Okay. So now brackets are removed. Let's check whether are there any like terms. Are there any like terms?
6p and 2p.
6p and minus 2p. P terms. 6p and minus 2p like terms. We'll bring them closer. 6p minus 2p. Okay. Now don't take
2q.
2p, just
2q
2p.
plus.
Definitely take with the minus 2p. Okay.
Okay, sir.
Yes, continue.
2q minus 2q plus 2q.
Not 2q here, minus 2q.
Okay, sir.
Okay.
Minus 2q.
Minus 2q plus 2q. Minus 2q plus 2q. Okay. Now these p terms I can simplify. 6p minus 2p, what is the answer?
4p,
4p, yes, good. Minus 2q plus 2q.
4q, plus 4q.
Yeah. Now from this one, 2q is subtracted. Again 2q is added. Okay, 2q subtracted, 2q is added. Like this. There's a person, I took 50 rupees from him. I took 50 rupees from him. Again, I gave that 50 rupees to him. Does anything happened? Does anything changed here? He had the 50
No,
rupees.
sir.
I took it and again I gave it. So nothing changed.
No,
So
sir.
no,
Nothing happens.
yes, this minus 50 and plus 50 get cancelled. Nothing happened. Zero change. This is also same thing. 2q is subtracted from this one. Again 2q is added. So no effect. 2q is
Then just
subtracted,
2q.
added. We can cancel out them. No change, zero change, therefore added. So cancelled. Here 2p is subtracted from 6p, then a change is there. Now 4p is remaining. Here nothing changed. Minus 2p will get cancelled with the plus 2p. So answer is 4p. 4p is the answer. Okay. Yes, we'll try one more before winding up. minus 4 times a minus m minus 2 times a plus m. Okay, minus 4 times a minus m minus 2 times a plus m. Okay, give it a try. Last one.
Sir,
Yes.
minus 4 into a minus 4a,
Minus 4 into a minus 4a. Yes.
minus into minus plus
Minus into minus plus
4m. Minus 4
4m.
into, oh, yeah.
Yeah, correct.
And minus into minus 2 into a is minus 2a,
Minus 2a, correct.
minus into minus minus into plus minus 2m.
Minus 2m. Yes. Now check whether are there any like terms. Yes. Here a, like terms. So we'll take the like terms closer. Minus 4a minus 2a. Here plus 4m. Here again minus 2m.
2m.
Now we can simplify these two like terms and these two like terms. Minus 4a minus 2a. What is the answer? Yes.
minus 2.
Minus 4a minus 2a. What is the answer? Yes.
Minus, what's sir? What's the question? Minus
Minus
4a
4a minus 2a.
2a.
Sir, minus 2.
Minus 6a, sir. Minus 6a.
Two answers are there. Minus 6a. Someone is telling minus 6a and other one is telling minus 2a. Let's see. Here, minus 4a minus 2a. When it is like this, do this one. When it is minus 4a and minus 2a, now here they haven't given any bracket, no? They have not given any bracket. So you put a bracket to this one and a bracket to this one and add the multiplication, so addition sign here. Okay, do this one whenever you feel confused, do this one. Minus 4a minus 2a, you cover the minus 4a with brackets and minus 2a with brackets and put an addition sign. Now what? Directed numbers, can you remember in grade 8 you may have learned directed numbers, okay?
Sir.
Yes?
Yes, sir. Yes, sir. We have learned.
Yes, you have learned. Minus 2 plus minus 3, when two directed numbers are adding, if their symbols are equal, what do we do? If the symbols are equal, here minus, here also
Add,
minus.
sir. Add. Minus
Yes.
into minus.
Add the numbers
Positive.
2 plus 3, that is 5. Write the same symbol. Answer is minus 5. Add the numbers, write the same symbol. But if the numbers are
Okay,
different,
sir.
if the signs are different, plus, here plus 3. If the signs are different, what do we do? Take the big number, subtract the small one from the big one. Here big one is 3, small one is 2. So 3 minus 2, answer is 1. Write the symbol of the big one. Big one is positive, therefore positive. Plus 1. Okay. So when adding two numbers, if their symbols are same, either both plus or both minus. If the same number, same symbols, when adding, add the two numbers, write the same symbol. Here minus, here minus, same symbol, 2 plus 3, 5, answer is minus 5. Here, when adding numbers with different signs, here minus 2, here plus 3, what to do? Add the two numbers, if symbols are different, subtract the small one from the big one, write the symbol of the big one. Okay, 3 minus 2, 1, big one is plus, therefore plus 1. Okay, right. Quickly tell me the answer for this one.
Minus 6a plus
Not
minus
A, just minus 6 plus 2. Tell me the answer. Minus 6 plus 2. Can you tell me the answer? Here, addition of directed numbers mean numbers with the plus or minus mark. Directed numbers, okay?
minus 4.
Yes. Adding directed numbers with different signs. Here negative, here positive. Then what to do? Take the big one. Here, no, actually big one is plus 2. But when comparing, we don't think about the sign. We just look at the number. If you take only numbers, here
Subtract.
6, here 2, then 6 is the big one. Then 6 minus 2, subtract the small one from the big one. 6 minus 2, that is 4. Then write the symbol of the big one. Big one is negative, therefore answer is negative. Minus 4.
Okay, sir.
Here also, we'll take it like this. Put two brackets, right, put an addition mark. Okay, we can do it like that. Then here minus 4a, here minus 2a, same symbol. What to do? Add the two numbers, write the same symbol. 4a plus 2a, that is 6a, minus answer is also minus 6a. Okay. Plus 4m minus 2m. 4m minus 2m. What is 4m minus 2m?
Plus 2m.
That is plus 2m. Answer is minus 6a plus 2m. Minus 6a plus 2m is the answer. Okay, we'll do one more question. Only one more. Next part we'll do tomorrow. Okay. Last one.
Sir, what's the class duration?
Normally 2.5.
Okay, sir.
Okay. Okay. Give a try for this one.
Sir,
Yes.
3 into a, 3 into minus a,
3 into minus a. Yes.
minus 3a,
Minus 3a. Okay.
3 into minus b, minus 3b.
Minus 3b. Correct.
And plus into minus minus 2
Plus into minus minus, yes.
and 2 into a 2a
2 into a, 2a,
2
good.
into minus a 2a
Yes, 2 into minus a, minus 2a. Correct.
and plus into plus
Plus
and 2 2b
2 into b, that is 2b. Okay.
2b.
Yes, plus 2b. Correct. Now check whether any like terms are there. Yes, here a, here also a. So I'll take the a terms closer, minus 3a, here minus 2a. Here b terms, here minus 3b, here plus 2b. Minus 3b plus 2b. Okay. Can we simplify these two?
Yes, sir.
Yes. What is the answer?
Minus 5a
Yes, very good. What to do?
minus
Put
into minus
brackets.
minus
Yes, not plus into minus minus. Here what do we do?
minus
Addition of
uh,
directed numbers with same symbol. Here also minus, here also minus.
okay,
Same
sir.
symbol mean, yes,
Okay.
add the numbers, write the same symbol. 3a plus 2a, that is 5a, minus minus, this is also minus.
5a
Minus
5a
3b plus 2b, what is the answer?
minus b
Minus b, yes. Minus 3b plus 2b, it is like this. Different signs, therefore minus 3b plus 2b, like this. So different symbols, here minus, here plus. Subtract the small one from the big one, write the symbol of the big one. Here 3b, here 2b, 2b is the small one. 3b minus 2b, 1b, big one is negative, therefore this one is negative, minus b. Answer is minus 5a minus b. Okay, minus 5a minus b is the answer. Okay. Yes, so we discussed today from the very beginning to what is the meaning of algebraic symbols up to expanding we talked. So tomorrow we have to do about yes, product of binomial expressions and square of a binomial expression and also the cube of a binomial expression. So we'll do that part tomorrow. Now tell me from the things that we learned so far today, are there any doubts or are there any unclear places? Tell me now, present your questions. I'm ready to answer. No any question? Why all are silent?
Sir, can you please say me the terms and that you said something name polynomial?
Sorry, I couldn't hear you. Can you repeat? Yes, can you repeat, please?
Sir, the terms monomial, binomial,
Yes.
trinomial, and polynomial.
Uh,
Before that, you teach something, right? Like linear expression. Can you please explain me that?
yes. Now that means algebraic expressions, we can classify them, we can group them into different groups. Based on their characteristics, we can classify them. Okay. We can classify algebraic expressions based on two criteria. First one is based on the number of terms. Number of terms. Okay, based on the number of terms. If an algebraic expression is having only one term, like this, here 2x, only one term is there. If there is only one term, we call it a monomial. A monomial. Okay. If an algebraic expression is having only one term, then that kind of algebraic expressions are called monomials, monomial expressions. Okay. If an algebraic expression is having two terms, 2x plus 1, two terms are there. If there are two terms,
Binomial.
we call it binomial. Okay, we call it binomial. Normally,
Yes, sir.
bi is used for two. And two terms mean binomials. If it is having three terms, 2x squared plus
Trinomial.
3x plus 1. Yes, three terms means we call them trinomial. Three terms mean trinomials. Now, basically, we have three special names. One term monomial, two terms binomial, three terms trinomial, four terms, five terms, six terms, so any terms, any number of terms, we call them polynomials.
Polynomial.
Polynomials. Normally, polynomials mean more than one term. If something is there more than one, we call it poly. Okay. In addition to monomials, all are polynomials. Binomials are also polynomials. Trinomials are also polynomials. So these are also polynomials, but they have two special names. Only when there are two and three terms, we have two special names. They are also polynomials, but specially we call them binomials and trinomials. So 2 terms, 3 terms, 4 terms, 5 terms, 6 terms, any number of terms, we call them polynomials. If it is only one term, we call it monomial. For these two, we have two special names as binomial and trinomial. So that is how we classify algebraic expressions based on the number of terms. Based on the number of terms. The other method is, now we can come to practical situations. If you are classifying animals, we can classify them into separate, different ways. No? We can classify them based on their places living. Animals living in water, aquatic. Yes, animals live in land, terrestrial, like that we can classify. Also, we can classify them based on their food. If they are eating meat, carnivores. If they are eating only plants, herbivores, like that.
Omnivores.
We can classify them based on different criteria. Like that. Algebraic expressions also can be classified based on different criteria. This is how we classify them based on the number of terms. Also, we can classify them based on the highest power of the unknown term. We can classify them based on the highest power of the unknown term. If the highest power is 1, 2x plus 1 here, unknown term is x, power is 1. So highest power is 1. If the highest power is 1, we call it a linear expression. If the highest power is 1, we call it the linear expression. Look at this one. 3x squared plus 2x plus 1. Here unknown term, here we have a x, here also we have x. But here power is 2, here power is 1. So in this expression, highest power of the unknown term is 2. Highest power of the unknown term is 2. If the highest power is 2, we call it what? Quadratic.
Quadratic expression.
Yeah, quadratic expressions. Quadratic expressions. Okay, if the highest power is 2. If the highest power is 3, like this, 4x cubed plus 3x squared plus 2x plus 1.
Cubic
Here,
expression.
x terms, yes. Here highest power is 3. If the highest power is 3, what do we call?
Cubic expression.
We call them cubic expressions. If highest power is 3, we call it cubic expressions. Okay, so that's it. This is the way we classify algebraic expressions. The other thing is, now I forgot to tell that. Yes, other one. Here, highest power of the unknown term is 1. So this is the term that contain the highest power of the unknown term. Okay, here in this expression, highest power of the unknown term is 2. Highest power of the unknown term is 2. This is the term that contains the highest power of the unknown term. Unknown, highest power of the unknown symbol is 2. Then this 3x squared is the term that contain the highest power. Okay, here highest power is 3 and 4x cube. This term 4x cube is the term that contain the highest power. So in an expression, the term containing the highest power of the unknown part is called, we give them a special name. These terms are called leading term. Okay, leading term. Normally in O-level syllabus, we don't use this word much, but keep in your mind, the term that contain the highest power of the unknown term is called the leading term. Okay, we call it the leading term. So keep that in your mind, okay? Highest power is called leading term. Okay, did you understand that one?
Yes, sir. Clear.
Okay, no need to think about this leading term concept much. It's not in our, we don't talk about that one in the O-level syllabus. We talk, but we don't use that one. But anyway, keep that in your mind. So here leading term is this one here. Leading term is 2x squared. Here leading term is 2x. Here only 2x is there, so leading and non-leading, everything is 2x. That's it. Okay. Any other doubts? Any other questions?
No, sir.
No, sir. Clear.
No. Other two?
No, sir.
No. One is remaining silent. I hope it is clear for you also. Okay.
Sir, all
So,
clear, sir.
huh?
All clear.
All clear. Okay, good. So then let's wind up today's work, and tomorrow at 7 p.m. also, we are doing the next part. So then see you tomorrow. We'll finish the tube tomorrow. Okay?
Okay, sir.
Okay, sir.
Okay. Then I'll close the meeting. Good night.
Thank you, sir.
Yeah,
Thank
you're
you, sir. Good
welcome.
night.
Good night.
You're welcome. Good
Sir.
night. Good night.